So in this presentation we have to talk about the plane wave solution. For that, consider the Dirac Hamiltonian of a free particle H equal to E equal to C alpha dot P plus beta mc square. Here alphas and beta are 4x4 matrices. Now allow the Hamiltonian operator to operate on the function psi. We can get the equation of form 1. Now we have to justify the value of psi. See here, alphas and beta are 4x4 matrices. Suppose a 4x4 matrix is allowed to multiply with another one matrix. That matrix should start with 4 rows. That is the rule. Therefore, psi is chosen as a column matrix with 4 elements. The equation 1 is equivalent to 4 simultaneous first order differential equations that are linear and homogeneous in 4 components, psi 1, psi 2, psi 3 and psi 4. Therefore, the plane wave solution is having the form psi j of r comma t equal to uj e power I k dot r minus omega t. Here j equal to 1, 2, 3 and 4. Now substitute the value of psi in equation 1. We can get E into U, which is equal to C alpha dot P plus beta mc square into U. Here U equal to U1, U2, U3, U4. It is a column matrix with the 4 elements U1, U2, U3, U4. These 4 elements column matrix should be reduced into 2 by 2 form. That is U equal to VW. Here V equal to U1, U2, W equal to U3, U4. The reason for converting this column matrix, the 4 elements, into a column matrix with 2 elements is explained below. See this equation. E psi equal to C into alpha dot P into psi plus beta mc square psi. Here the alpha dot P is 0 sigma dot P into 0, because alpha equal to 0 sigma 0. We know the value of alpha x equal to 0 sigma x 0, alpha y equal to 0 sigma y 0, alpha z equal to 0 sigma z 0. Therefore, in general, alpha equal to 0 sigma 0. So, alpha dot p equal to 0 sigma dot p 0. Here, sigma is nothing but our Pauli spin matrix, which is 2 by 2 in form. So that this column matrix is the 4 by 4. This column matrix is the 4 elements is reduced into a column matrix with 2 elements. Actually, the dimension is 2 by 1. This dimension is 4 by 1. Now, instead of U, see this U, instead of U, we have substituted VW. Here C is present as such. This alpha dot P is replaced by 0 sigma dot P 0. Then U is replaced by VW. Here beta is I0, 0 minus I. Already we have discussed the same in the Dirac matrices. Then mc square is present as such. Then U is replaced by VW. Now the above equation is modified as E into VW equal to 0 C into sigma dot P, then C into sigma dot P 0 VW plus mc square into mc square 0 0 minus mc square VW. If you make the matrix multiplication, E into V into W, this is 0 into V plus C into sigma dot P into W. So the first term is present. Here C into sigma dot PV plus 0. So this is our entire matrix. Here mc square into V plus 0 into W, then 0 into V minus mc square into W. So we can have this matrix. Now we can write from equation 4, E into V equal to C into sigma dot P W plus mc square into V. Then bring this mc square into V to the left hand side, we can get E minus mc square into V equal to C into sigma dot P W. Equation 6 is arrived. Now consider the second term, E into W equal to C into sigma dot P V minus mc square into W. Bring this minus mc square into W to the left hand side, we can get E plus mc square entire is multiplied by W equal to C into sigma dot P into V. Now multiply both sides of equation 6 by E plus mc square. See, E plus mc square into E minus mc square into V equal to C into sigma dot P E plus mc square into W. Replace the value of E plus mc square into W by C into sigma dot P V using equation 8. Instead of E plus mc square into W, we have to substitute C into sigma dot P into V. So the right hand side is modified as C into C square, sigma dot P into sigma dot P whole square into V. Then the left hand side is A plus B into A minus B equal to A square minus B square formula I have used. So E square minus m square C power 4 is multiplied by V. Now this is the explanation for sigma dot P I have given. Then sigma equal to I into sigma x plus j into sigma y plus k into sigma z. Then P equal to I into px plus j into py plus k into pz. I dot I1, j dot j1, k dot k1. So you can have sigma x px plus sigma y py plus sigma z pz. All other terms are 0. Then I have substituted the value of sigma x, sigma y and sigma z. If you do the multiplication and addition process, we can get the value of sigma dot ps pz px minus ipy, px plus ipy minus pz. This is our p minus, this is our p plus. So pz, p minus, p plus minus pz is the value of sigma dot p. If you make the square, you can get p square. So in this case, instead of sigma dot p whole square, we can write p square. So the equation 10 becomes E square minus m square C power 4 into V equal to C square P square into V. Bring this C square P square term to the left hand side. We can get E square minus m square C power 4 minus C square P square. Entire is multiplied by V equal to 0. Here V not equal to 0. Therefore, E square minus m square C power 4 minus C square P square is equal to 0. Then E square equal to C square P square plus m square C power 4. Finally, we can have the value of E equal to plus or minus root of C square P square plus m square C power 4. We can say Dirac equation gives positive and negative solutions as in the case of Klein-Gordon equation. Now we have heard energy eigenvalues. Energy eigenvalues can have both positive and negative values. Now we have to develop the eigenfunctions. We can have 4 eigenfunctions, 2 eigenfunctions corresponding to the positive energy state and the other 2 eigenfunctions corresponding to the negative energy state. For E plus and E minus, we can have in total 4 solutions. First of all, we have to find the solution for E plus. Before that, consider the equation carrying V. See this equation. From 6, we can have the value of V equal to C into sigma dot P into W divided by E minus mc square. This equation is arrived. In this equation, suppose the value of P equal to 0, then the value of E is replaced by mc square. Then the value of V is infinity. Instead of E, we cannot put E plus, but we should put E minus. If it is E plus, the E plus value equal to mc square. So mc square minus mc square 0, anything by 0, infinity. Therefore, whenever you use E minus mc square, we should use E suffix minus minus mc square. If you want to use the term E plus mc square into W term, instead of E, we have to use the positive energy E plus. Now we have to find out the value of energy eigenfunctions corresponding to E plus eigenvalue. For that, equation 8 is considered. From equation 8, see the equation 8. From this equation 8, W equal to C into sigma dot P V whole divided by E plus mc square. Here this E should be replaced by positive energy, E suffix plus. Say this is the value of W. Here we may get 2 solutions by the way of considering V as 1 0 and 0 1. 1 0 is spin up state, 0 1 is spin down state. By considering the value of V as 1 0, we can get the value of W. See, C into sigma dot P divided by E plus mc square value is this much. Already we have had the value of sigma dot P value. So this is the value of C sigma dot P divided by E plus mc square. then we have considered the value of V as 1, 0. If it is the case, we can get the value of W as this much. Now the first solution is U of 1 equal to VW. The value of V is arbitrarily chosen as 1, 0. If you consider V as 1, 0, the arrived value of W is this much. Substitute this value. This is the first solution. Next, we have to consider the value of V as 0, 1. If V equal to 0, 1, then we can get a value of W by substituting C sigma dot P divided by U plus MC square value. That should be multiplied by V 0, 1. We can get the value of W this much. Now the second eigenfunction is U of 2 equal to VW equal to 0, 1. This is the value of V. This is the value of W. Now we have had two eigenfunctions corresponding to the positive energy state. In the same way, we can get two other eigenfunctions for the negative energy state. For E minus, we can get two solutions. For that, take the value of V. Then the value of V is arrived from the equation, see here, 10. V equal to, not 10, see this 6. V equal to C into sigma dot P divided by E minus MC square into W. Using that equation, see, this is the value of V, C into sigma dot P divided by E minus MC square into W. Consider the values of W are 1, 0 and 0, 1. If W equal to 1, 0, we can get the value of V in this way as this much. Now we can write the third solution. While writing the third solution, care should be taken because the value of U equal to V W. So the value of V should come first. Then W is 1, 0. For the fourth solution, W is chosen as 0, 1. Then V equal to multiply this quantity by 0, 1. This is the value of V. Now the fourth solution, U4, is given as these are all the values of V. Then W equal to 0, 1. In this way, we have had the two solutions for the negative energy state. See, in the solutions U1, U2, U3 and U4, the U1 and U2, see here, the first two components, 1, 0 and 0, 1 are called large components, and the second two components, these two and these two are called smaller components. Whereas U3 and U4 are concerned, the first two components, these two, U3 as well as in U4, these two are called as smaller components, and the last two terms, 1, 0 and 0, 1 are called large components, because as we decrease P, the third and fourth components of U1 and U2 decrease and finally become 0. Hence the first and second components are called as large components, third and fourth are small components. In the same way, for U3 and U4, the third and fourth components are called as large components. So in the non-relativistic limit, when the momentum is very less, then the smaller components are reduced into 0. Which means that the solutions U1, U2, U3 and U4 are presented in this form. These components are treated as 0, no meaning for that. So this is a non-relativistic eigenfunction. That's all about the planar solution.